Hello everyone. In this session, we are going to discuss about the remaining topics of the first unit, understanding how deep learning works and what achieved in the deep learning so far, and what is the promise of AI for the future. So it is the last three concepts of the first unit. And now let us try to understand how deep learning works. In this, you can observe that in the part of the input, we can say that here in this diagram, you just see this diagram here, there will be the input, and the output will be somewhere. Actually, there is the output also available. Here we are not mentioning that. There is the output. And now the input will be given to the model as we discussed. It is the layered model. There is the layer 1, there is the layer 2, and there will be the number of layers. So how it works is the input will be given into the layer 1, and the layer 1 will have the number of weights also connected. So what are those weights? Let us say, for example, X is having input X is having three attributes. Let us say, for example, X1, X2 and X3. Three attributes are there. Three attributes are three inputs. X is having three inputs. So for these three, there will be the three weights provided. Three weights. One, weight 2 and weight 3. These three will be given for these three inputs, meaning that the input 1 into the weight 1 plus input 2 into weight 2 plus input 3 into weight 3. So how we can get this is the X and W. We can say that the output will be the process inside the layer will be like this: W1 X1 plus W2 X2 plus W3 X3. This will be the process inside the layer. And of course, inside the layer, there will be the number of units. So this is one unit process. And these type of units may be, number of units will be there. 1, 2, 3. Let us say, for example, layer 1 is having 5 units. So the given input will be multiplied with the given weights. Of course, they are also called the parameters. Since we are using the parameters or weights, it is called the parameterized algorithm also. So the learning process of this particular model is like identifying the proper weights or estimating the proper weights to get the proper output. So as the part of that, initially we will take these random weights. Here the W1, W2, W3, these are the random weights initially we will take. And inputs will be the X1, X2, X3. W1 X1 plus W2 X2 plus W3 X3 will be calculated in such a way layer 1 may have the number of units. For each unit, the W1 X1, W2 X2, W3 X3 will be calculated. And for the next unit also, W1 X1 plus W2 X2 plus W3 X3 will be calculated. And once if it is done, then it will go to the next layer. In the next layer, let us say, for example, layer 1 is having 5 units. 5 units are there. Now, how many outputs will be there? How many units are there? Those many outputs will be there. 1, 2, 3, 4, 5. So the 5 outputs are produced by the layer 1. These 5 outputs will be the input for the layer 2. So this is the input 1, input 2, input 3, input 4 and input 5. So these are the various inputs. Now in this, again the weights, how many weights required? These 5 inputs are there for the layer 2. So 5 weights will be created. W1, W2, W3, W4 and W5. 5 weights will be created. So again the same formula will be applied. Here also we can call it as the X for this layer, X1 and W1, so that here the equation will be again W1 plus X1, W1 into W1 X1 plus W2 X2 plus W3 X3 plus W4 X4 plus W5 X5. So in this way, one value, the output will be generated for layer 2. So based on this, we will get the output. Let us say, for example, here prediction, the output is only one output. So here also the layer 2 is producing, meaning that layer 2 is having only one unit. Layer 2 is having only one unit, so that it is producing only one unit. So that is the prediction Y, meaning that the output, the final output of this particular model is W1 X1 plus W2 X2 plus W3 X3 plus W4 X4 plus W5 X5. That will be the output. That is also called the prediction or predicted output. That is called that is represented with Y dash. Input is the X and output is the Y, and the predicted output is the Y dash. It will be represented with Y dash. What is this output? This is we only calculated based on the random weights. We calculated this output. Now, definitely it will be different. It will not be equal to the original Y, because it is not considering that output. So we are taking the random weights. So definitely there will be the difference between the Y and Y dash. In this case, if you are able to adjust these weights, inputs we cannot adjust because they are fixed. So if you are able to adjust the weights, then it will be the, we can reach the Y very close to Y with the Y dash. So how can we update these weights? To update the weights, first of all, you have to understand what is the difference between the Y and Y dash. For that, we have to go for, for that we have to go for the loss function. The loss function is a function which will calculate the difference between the original output and the predicted output. Here, what is the origin? This is the original input, and this is the original output. This is represented with Y, and here you can observe that this is the old diagram only. Up to here, this is the old diagram in the previous slide. So if you see that previous slide, the same thing we are using here. Okay, and now the original output, as I mentioned you, the original output is Y, the predicted output is Y hat or Y dash, and the loss function, we will give that loss function means Y minus Y dash, Y minus Y dash, difference between these two. That will give you the loss. Of course, there are so many loss functions available. Y1, Y minus Y dash, or Y minus Y dash square, or like this. There are so many functions are available. In that, the loss function will calculate the loss, and it will give you the loss score. So it is the error. Loss means it is the error. Now, how can we handle this error? We have to handle this error. How can we use this error? To utilize this error, we can go for the another algorithm, meaning that we have to take this loss, and we have to adjust these weights based on this loss. So meaning that in between we should have something here. That is called the optimizer. That is called the optimizer. So what the optimizer will do is, see here, this is your first diagram, and the second diagram which includes this, and in this third diagram we are adding this path. Okay, now in this we calculated the loss here, and that loss score will be taken, and based on this loss score the optimizer will optimize, and it will identify what are the weights to be updated, for the each and every layer, so that this optimizer will change the weights of the layer 2. This is layer 1 and this is layer 2, and also this optimizer will update the weights of layer 1 also. So this is the layer 1. So the optimizer plays an important role to adjust the weights so that it can learn. So once if it is changed the weights, again we will run the same process, meaning that again we will calculate with the updated weights, we will calculate the W1 x1 plus W2 x2 plus W3 x3. We will calculate. Again there are 5 units we are assuming. So again for the layer 2, the updated weights W1, W2, W3, W4, W5. So they will be multiplied with the x1, x2, x3, x4, x5, and it will generate the prediction. So that the prediction y dash. Again we will calculate the loss score by using the loss function. Again we will optimize the weights so that till you get this y dash is closer to the original y. So what we are providing? We are providing the original value, original input x and original in output y. So this is what we are expecting, and in middle we are taking the weights and loss function. Weights we are taking as the random, and loss function we are calculating the predicted output by using the weights on the input, and we are calculating the loss score by using the loss function by considering the updated weight, calculated weight and the original calculated output and the original output. And based on this loss function, loss score, the optimizer will update the weights. How much updation should be required, that will be calculated, and that will be given to the weights, so that the weights will be updated, and the layers again the process will be continued till you reach very close to the original output y. So y and y dash should be close enough. Then you can stop this iteration. This iteration is called the epoch. We will call this as epoch. So epoch 1, epoch 2, epoch 3 and so on. Number of epochs we have to run. That is called the learning. This epochs is called number of times weight calculation, number of times the optimization, number of times the loss calculation. This process is called the learning. So 1 epoch, 2 epoch, 3 epoch. In this way number of epochs will be generated, and number of epochs will be run to reach the original target. And now what we have achieved so far, this is in the brief about how the deep learning is working. We will discuss in detail about this weight updates and all in the coming sessions.